Hi everyone, good morning. Yes, do you have any questions in the last session? All right, if you don't have any questions, we'll go to the next part. So yesterday we just have started with this mini project and we are just doing the analysis, right? And this was the last part that we have studied. So we have this series basic functions and we have data frame basic functions. We'll see it one by one. Right. So shape will give you the size of your data. This size will give you the number of elements in the data frame. Values will give you the numpy representation of the data frame. Head, as you know, head you will get the first five and tail you will get last five rows. So let us do this. Then for descriptive statistics, we have describe function. So what are the different functions that we have? We'll see this descriptive statistics in pandas. So there exists a large number of methods for computing descriptive statistics and other related operations in series, data frame, and panel. Most of these are aggregations, like we have functions and description. We have count, we have sum, then we have mean, we have median, we have mode function, then we have standard deviation, we have minimum value, and we have maximum, absolute, product, cumulative sum, cumulative product. So let us create a data frame 4 and let us write down df.copy. And if you check df4.max, you'll be able to get the, we need to restart and run all this. So if you're at df4 of max, you'll get the maximum value for that particular column. Let's say max of 0 if you write. So user ID जहाँ पे मैक्सिमम है वो रिकॉर्ड्स आपको मिलेगा वहाँ पे. Then as we know, df.describe what it does, it will give you the descriptive statistics, count, mean, standard deviation. Now we have one more thing which is known as correlation. So we'll get the correlation matrix and we can easily find the correlation between two independent variables over here. Then we have aggregate function that we can make use of. Let's go with that. Aggregations in pandas. So let's say I'm creating a copy df5 or df6 equal to df.copy. And what I'm doing is df6.aggregate nv.sum. Or let's say df6 may.
Hello. Hello.
Yes.
Sir, wait a minute for a 2 minute. Hello.
Yeah, we need to wait for some time.
Yes, sir. Uh, Kindly everyone message your trainee ID in the chat box. Everyone kindly message your trainee ID last 2 digit. Okay. Please check the group and message on the chat box. गौतम वैभव विनय अभय हर्ष अतुल प्रियांशु प्रशांत प्लीज क्विक. Regularly after joining the session, after 15 minutes, please put your trainee ID in the chat box. Okay. Please message on the chat box. Okay. On the time. Sir, you can continue. Okay. Sir, you can continue.
Yeah. So let us go for purchase column. And we want to make use of aggregate function. We want to find sum of that. So purchase column के लिए, what is the sum? We'll get this. So I think it will take time. Like that, suppose आपको sum purchase column के लिए, let's say if you want sum as well as if you want mean, we can do this over here and you can run the same. So यहाँ पे purchase column के लिए sum and mean आएगा वहाँ पे. Similarly, suppose आपको multiple columns के लिए find करना है, तो what you can do is you can write down purchase. As you are making use of multiple columns, so you should use double square bracket over there. Then let's take product underscore category underscore 1 comma product underscore category underscore 2, comma, product underscore category, C is capital. In our column, C is capital, right? Underscore 3. Now, if you do this, you would be able to get the sum and this. As this is a heavy function, that is the reason it takes time generally. Now let us go with this merging and joining, which we have discussed. Before that, we have discussed group by as well, right? So what is group by? So I'll just write down the notes for group by. Group by operations. This thing, what do we do is we split the object, we apply a function, we are combining the results. So generally what do we do is we just write down, let's say df6 dot group by for gender column. I'll just restart and run all this. I don't know why this is taking time. I'll just close this and let us restart it one more time. Now let us restart and run all this. And let's try to do the group by. Group by on, let's say, gender column. And we want to find sum of this gender column. So it is coming, right? Now जेंडर कॉलम के लिए ही सेम आउटपुट अगर चाहिए आपको तो यू कैन डू लाइक दिस df6 डॉट ग्रुप बाय सेम आउटपुट अगर चाहिए वी हैव डिफरेंट थिंग डॉट np agg np dot sum. If you write this, you'll get the same output, right? So what do you have in your data? ये जो एज कॉलम है, सॉरी जेंडर कॉलम है, जेंडर, तो फीमेल एंड मेल वाइज सबका आपको सम मिलेगा. यूजर आईडी, सो यूजर आईडी का भी उसने सम निकाला है, प्रोडक्ट आईडी का भी सम निकाला है, Then you'll have occupation. So occupation का female wise sum कितना है? You have this thing. So likewise for all the columns you'll get this sum. Another way in which you can go with the group by is, let's say multiple column के लिए करना है आपको df6 dot group by gender column, purchase column dot agg np dot sum comma np dot mean. If you do this, आपको जेंडर कॉलम के लिए फॉर स्पेसिफिक परचेस कॉलम के लिए आपको उसका सम आएगा और मीन आएगा, राइट? So likewise you can do depending upon your applications or question. जेंडर कॉलम के लिए, ऑक्यूपेशन के लिए, सॉरी नॉट ऑक्यूपेशन, परचेस के लिए you will get the mean and sum over there. Now let us go with the merging. Pandas merging and joining. So if we want to merge two data frame, we can use this. And how the syntax is, how the syntax goes like is, you need to write down this thing. And if you go to the official documentation of merge pandas, you will get this thing, right? This is the syntax. So यहाँ पे आप left, right, how, inner, on, left on, ये सब जो है parameters यहाँ पे देख के उसका description देख के you can write down, right? Now what you can have is, let's create two data frame and let's try to use this. Create two data frames. First is batsman is equal to pd dot data frame id column. For id you have 1 comma 2 comma 3 comma 4 comma 5. Let's say next column is name. So you have this name. Let's say let's add this in subject id is equal to, in a list will pass subject 1 comma subject 2 comma subject 3 comma subject 4 comma, let's go for subject 6 and subject 5, right? And let us close this batsman data frame. Second, we have bowler data frame. So pd dot data frame. Let's create a dictionary. And in this thing, let's pass id as, in a list 1 comma 2 comma 3 comma 4 comma 5. Then we have name column. In a list, we'll write down Kumar comma Bumrah comma Shami Kuldeep Chahal comma. Next is subject underscore id, and that will write down subject 2 comma subject 4 comma subject 3 comma subject 6 comma subject 5. And you'll close this. Then you are going to print the batsman. Double quote comma again. Name comma is remaining over here. What do you have? Batsman video data frame. Must be of same length. Okay. We have given 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Acha, 4. Then 3 should not be there. We need to delete this. So this is your batsman, right? This is your data frame. And if you print another data frame, so this is your another data frame. Now let's see how you can merge this two data frame. Merge two data frame on a key. So pd dot merge. क्या merge करना है आपको? Batsman data frame and bowler data frame. On which common column? ID common column. So देखो, you have merged this, right? Let's say you want to merge two data frames on multiple keys. pd dot merge batsman comma bowler comma on is equal to id comma subject id. If you run this, bowler comma on subject id. That's spelling S is capital. All right. अच्छा, ये यहाँ पे this is what we have given. So you should copy this. Both columns should be same, right? So ये जो subject ID है और ये भी subject ID, it should be same like this. So these are the two data frame we have joined based on the subject ID. तो देखो यहाँ पे धोनी जो है, धोनी उसका सब्जेक्ट आईडी 6 है. सेम गोज विद कुलदीप, राइट? तो ये कॉमन है इसलिए वो दे रहा है. और केदार एंड चहल, इसका इन दोनों का भी सब्जेक्ट आईडी है 5. Now we have different arguments merging data frame on the how. So merge using how argument. How you can do is this thing is merge method. First is your left, how is equal to left. In this thing you'll have left outer join. Then you have right. In this thing you will be having a right outer join. Then you have outer. In this thing you'll be having full outer join. Then you have inner join. Now left join, you can write down pd dot merge. What you want to merge? Batsman with bowler comma on is equal to subject id and comma how is equal to left. This is S is capital. So this is just a left join. What is left join? Common table from the all the records from the left table and common from the right table. So left table जो था batsman उसके सारे records है यहाँ पे if you see, but only common records. तो ये मैच हो रहा है, ये मैच हो रहा है, ये मैच नहीं हो रहा है. ID number 1 from the right table. I think we have discussed this merge, yes or no? Merge is done or not? for your batch. किसमें किया था ये? ग्रुप बाय में किया था, राइट? ग्रुप बाय. See, this is how you have merged the two data frame, right? So this is what we have. There are n number of functions that we can make use of. Concatenation भी एक है. To concatenate मतलब to add the two data frame. Let's say यही दो data frame को what we'll do is we'll just see what is concatenation. So team is equal to batsman comma bowler, and we'll write down pd.concat. किसको करना है? आपको team को करना है. So it will batsman. Spelling is wrong. So देखो batsman and bowler को we have concatenated this, right? If you just read concat this function, you'll get an idea about this. Then moving further, we have concatenating using append. तो आपको क्या करना है? Suppose batsman dot append मतलब ऐड करना है basically bowler data frame. So ये दो data frame we have successfully added, batsman and bowler. Now we can stop here for this thing and let us go for next part. So outlier detection is done for your batch. Encoding is also done. Custom summary we can see, right? So let us create new folder and let us write down the day8 Python. And in this thing you'll require data. So data will want system. Xiaomi raw data. So this you can take. Let us create new notebook. Let's rename this as custom summary. And what we'll do is we'll import pandas as PD. Import numpy as np. Then we'll read the data, pd dot read underscore excel and Xiaomi data. Let us go with this first. I think this is not the correct file. Let's check. And let's check the head of the data. This is what we are right. So df dot shape. How many records do we have? We have 43,200 rows. And how many columns do we have? We have this columns, right? Sorry, 7 columns. And this is your descriptive statistics, right? बट इसमें आपको सिर्फ काउंट मीन स्टैंडर्ड डेविएशन मिनिमम 25%, 50% एंड 75% एंड मैक्सिमम ही मिल रहा है आपको, राइट? बट व्हाट अबाउट द वेरिएंस वैल्यू? सपोज आपको वेरिएंस चाहिए, स्टैंडर्ड डेविएशन चाहिए, आउटलायर का डेटा चाहिए, आउटलायर है कि नहीं ये कॉलम में, या फिर स्क्यूनेस एंड कर्टोसिस चाहिए. तो व्हाट यू शुड डू in the output? You are not getting this values, right? But if you want this values as well, suppose your manager or your client ask that they want the outlier, skewness, kurtosis, standard deviation, variance in the descriptive statistics output. And what you should do for this? Should go with the custom summary. So we are going to create our own custom summary function, which will give you this thing. So we will create this function now. What are the columns that you have? You have this columns. But सब कॉलम के लिए आपको डिस्क्रिप्टिव स्टैटिस्टिक्स मिल रहा है क्या? इफ यू सी कस्टमर नंबर ऑफ क्लिक्स पेजेस व्यूड टाइम एंड अमाउंट स्पेंड के लिए मिल रहा है, सिर्फ डे ब्राउजर के लिए नहीं मिल रहा है. सो इफ यू ऑब्जर्व, ये कॉलम का डेटा टाइप क्या है? ऑब्जेक्ट. तो जो कॉलम ऑब्जेक्ट है, मतलब जो कॉलम कैटेगोरिकल है, स्ट्रिंग है, टेक्स्ट है, उसके लिए स्टैटिस्टिकल और डिस्क्रिप्टिव स्टैटिस्टिक्स का आउटपुट नहीं मिलता है. व्हाट यू शुड डू, यू शुड पास अ लूप. कॉलम्स इज इक्वल टू ब्लैंक लिस्ट फॉर I in df dot columns. You are going to print I. तो ये सारे ये तो सारे कॉलम्स है, बट वी वांट टू पास अ कंडीशन. कि कंडीशन क्या है? इफ अगर df ऑफ I का डेटा टाइप इज नॉट इक्वल्स टू ऑब्जेक्ट रहेगा, मतलब ऑब्जेक्ट को एक्सक्लूड कर दे अपन, तो विल प्रिंट दिस I. So print I. Now if you see customer number of clicks, pages, time and amount spent, same output you are getting it for describe, right? Customer number of clicks, pages viewed, time and amount spent, same output you are getting it for describe. So we don't want to print this, we want to add this in our blank columns list which we have created. Columns dot append I is remaining over here. तो कॉलम्स में क्या होगा? अभी ब्लैंक लिस्ट है ना, बट यहाँ पे अपेंड कर रहे हैं, मतलब जो ये जो कॉलम्स है सारे, वो कॉलम्स ब्लैंक लिस्ट में आएंगे आपके. एंड इफ यू जस्ट search what is there in columns, so you have this columns, right? Now we'll go for a function, but before that let's take a quick break for 5 minutes. Just 5 minutes. I'll just create this function and we'll take a break. So ये जो function है, इसमें आपको सारा values डालना है जो चाहिए वो, right? So it's 11:41. Let's have a break till 11:47. So we'll go with the custom summary now. Now I'll just write down the code, and once the code is done, I'll be explaining you everything line by line, right? So for call in my underscore df dot, if my underscore df of call dot data type is not equals to object, then I'm going to create a stats blank dictionary, and in this thing we'll just import the ordered dict. So उसका package है from collections, import ordered dict. Now what is ordered dictionary? It simply remembers the order in which you are passing the your columns. So in very rough or simple words, जो आप जो आप कॉलम के नाम डाल रहे हो ना, वो सीक्वेंस वो मेंटेन करेगा. Normal dictionary might not remember the sequence in which you are passing the column. Now what I mean by this is, अगर मुझे फीचर नेम फर्स्ट कॉलम चाहिए मेरे आउटपुट में, तो ये ऑर्डर डिक्ट रिमेम्बर करेगा सीक्वेंस. अगर मुझे काउंट सेकेंड कॉलम चाहिए, तो my df of call dot count open close bracket comma minimum of call dot mean quartile 1 my df of call dot quantile 0.25, राइट, कॉमा. तो ऐसे आपको क्वार्टाइल 1, क्वार्टाइल 2 और क्वार्टाइल 3 चाहिए. तो ये क्वार्टाइल 2 it will be 0.5, then you will have quartile 3 which will be 0.75, right, comma, you will create mean column minus df of call dot mean open close bracket comma, then you want maximum, so maximum minus df of call dot max comma variance round of my df of call dot var comma 0. Linear standard deviation my df of call dot st. Yeah, skewness my df of call dot ski aw skew and comma kurtosis, which is my underscore df of call dot qi kurtosis open close bracket. ये हो गए कॉलम सारे. अभी ये जो रिजल्ट ब्लैंक लिस्ट बनाया था, ये इसमें विल अपेंड दिस. क्या अपेंड करना है? स्टैट्स. तो जो स्टैट्स जो बनाया है, स्टैट्स में ये सारा है, वो अपेंड कर रहे हैं अपने रिजल्ट ब्लैंक लिस्ट में. or we need to now we need to create a data frame. Result underscore df is equals to, it should be in for, so we should data frame बना रहे out of this pd dot data frame and result. Then we'll go for skewness type. We will write down skewness underscore label is equal to blank list for I in result underscore df of skewness if I is less than or equals to -1. ये जो skewness label बनाया है blank, उसमें append करेंगे तो ये जो range है highly negatively skewed. Now what is skewness and what is kurtosis? We have not studied this. Let us try to understand this point. So we have skewness, right? Skewness. Now what is skewness? Let us take a figure for that. It checks your distribution is symmetric or not. So we can have three types of skewness. First is positive skewness. So I'll just write down definition. It checks whether the distribution is off centered or not. It will check whether the distribution is off centered or not. So how it generally checks is, this is your symmetrical distribution, right? Then you have positive skewness, where means 50% data will be on the left hand side, 50% data would be on the right hand side. Then you have the positive skewness. How to identify this? If you have tail, this is your tail. If your tail is on the right hand side, it is positive skewness. And if your tail is on the left hand side, it will be a negative skewness. Is it clear now, everyone? What is positive, what is negative, what is symmetric? So we have three types of skewness, and we have different ranges for skewness. So values k according different types of skewness we have. No, why is it slow? See, these are the values that you have. अगर तुम्हारा skewness का value, we generally write down df.skew to get the values of a skewness. What we do is we write down df.skew, get the values. So the values are there, right? And what is the range for three types? है ना? We have symmetrical, we have positive skewness, and we have negative skewness. Now if you see symmetrical मतलब -0.5 से लेके 0.5 अगर है आपका skewness, तो it will be a symmetrical skewness. पॉजिटिव मतलब क्या है, उसका रेंज है greater than 0.5. So if it is 0.5 से ज्यादा है, if it is greater than 0.5, it will be positive skewness. And if the skewness value is less than -0.5, it will be negative skewness. Now, is it clear for everyone what do you mean by skewness? Yes? Is it clear for everyone? Now, if this is done, we will try to study the next, kurtosis. So next we have kurtosis in statistics. Kurtosis. So it will give you the height of the distribution. It just gives you the height of the distribution. Kurtosis. If you just search this, you'll be able to get the height of the distribution. Now, this is your kurtosis. And this is your diagram. So let's take this and let us paste it over here. So we have three types of kurtosis, as you can see. First is leptokurtic, second is meso, third is platy. Now, agar tumhara distribution, if it is heighted like this, it is your leptokurtic curve. If it is in between, always, if it is in between this, that is mesokurtic, and this is your platykurtic. This will be platykurtic, right? So this is what we have. So three types है. सबसे heighted है, उसका नाम है leptokurtic. Then middle है, उसका नाम है mesokurtic. And then we have platykurtic, right? So जितना ज्यादा आपका डिस्टेंस है, सपोज ये है platykurtic, right? जितना ज्यादा डिफरेंस है between your mean and data points, ये सारे डेटा पॉइंट्स रहेंगे यहाँ पे ऑब्वियसली, उतना your bad will be the data. So platykurtic के लिए you'll have mean as very bad, so your data is poor because आपके मीन से बहुत ज्यादा डिस्ट्रीब्यूशन है डेटा का, द डिस्ट्रीब्यूशन इज वेरी हाई. बट लेट्स कंसिडर leptokurtic के लिए क्या हो रहा है वहां पे, द डिस्ट्रीब्यूशन इज वेरी स्टीप, राइट? इट्स लाइक दिस. सो सारा डेटा मीन के आजू बगल में प्रेजेंट है वहां पे, राइट? So you can consider that your data is good over here. So how your kurtosis will help you out is it helps you to get whether mean is good or bad. How mean is good or bad? If the distance is high, if the distance is high. Distance of what? Of data points with respect to mean is high. Then what you can say? You can say that mean is poor. Mean अगर poor है तो data भी poor होगा. And vice versa. Now is it clear for everyone the three types of kurtosis and how it helps you out? Is it clear for everyone? So this is what we have. Now we'll just the reason why I have explained this is because we are calculating the skewness and kurtosis. So यहाँ पे मुझे range देना है. तो अगर less than -1 रहेगा तो it is highly negatively skewed. Else if the skewness value is in between -1 to -0.5, it will be moderately negatively skewed. Again, else if it is in between 0 - 0.5 to 0, then skewness underscore label dot append, it will be fairly negatively skewed. And else if अगर 0 in between 0 I and 0.5, अगर skewness का value ये है तो it will be, इसका spelling wrong is skewness. So it will be of what type? Skewness underscore label dot append. It will be fairly positively skewed. And again, else if your skewness is in between 0.5 to less than or equals to I to less than 1. So it will be moderately positively skewed. So I can take this out, can paste it over here. Instead of negatively, it will be positively. And last, else if I अगर greater than or equals to 1 रहेगा तो it will be positively moderately नहीं, यहाँ पे होगा highly positively skewed. So highly negatively, moderately negatively, and these are the ranges that you have for skewness. Now if this is done, तो अपना जो result data frame है, result underscore df, इसमें एक column बनाने का अपने को, skewness comment, which will be skewness underscore label. This will be a column. Now वैसे ही आप kurtosis का भी कर सकते हैं, just like this. You can create it for kurtosis type, kurtosis underscore label is equal to blank list for I in result underscore df of kurtosis column. If your I is greater than or equals to 1, kurtosis underscore label dot append leptokurtic curve. Else if I is less than or equals to -1, it will be kurtosis underscore label dot append. We'll have platy kurtic curve, and else kurtosis underscore label dot append. We'll have meso kurtic curve. And then result underscore df of kurtosis comment, it will be kurtosis label, and then we are going to return our result underscore df. How to call this function is to write down custom summary function, paste it over here, and you have to pass df over there. Mean is my df is not defined. My this is wrong. My underscore df. So if you see, you are getting the output, right? इसमें आपको कर्टोसिस और स्क्यूनेस का वैल्यूज, स्टैंडर्ड डिविएशन का वैल्यू, वेरिएंस का वैल्यू और कमेंट भी आ रहे हैं वहां पे. So this is how you can create the custom summary function. Is it clear for everyone now? How we generally create the custom summary? I'll just uh, explain what we have done line by line. लाइन नंबर 1 में फंक्शन क्रिएट किया है, लाइन नंबर 2 में ब्लैंक लिस्ट क्रिएट किया है, लाइन नंबर 3 में फॉर कॉलम इन my underscore df dot columns, if my underscore df of column dot data type is not equals to object. तो यही यही ये जो earlier we have done this same thing. So ऑब्जेक्ट जो कॉलम है उसको एक्सेप्ट वो कॉलम के लिए आप डिस्क्रिप्टिव स्टैटिस्टिक्स निकाल रहे हो, राइट? नाउ stats is equal to order dict. I have explained why we require order dict, because यहाँ पे देखो फीचर नेम फर्स्ट कॉलम है आउटपुट में, सेकंड कॉलम में काउंट, थर्ड है मिनिमम. फर्स्ट कॉलम क्या है? व्हाट इज द फर्स्ट कॉलम इन द आउटपुट? इट इज फीचर नेम, काउंट, मिनिमम, क्वार्टल 1, क्वार्टल 2, right? Then mean, maximum, variance, standard deviation, skewness, and kurtosis. These are the columns. We are appending this in the stats. मतलब रिजल्ट जो ब्लैंक लिस्ट है उसमें जो स्टैट्स है वो अपेंड कर दे, और एक डेटा फ्रेम बना रहे उसका नाम है रिजल्ट अंडरस्कोर डीएफ. फिर स्क्यूनेस अंडरस्कोर लेबल एक ब्लैंक लिस्ट बना रहे, वो ब्लैंक लिस्ट में ये सारा अपेंड कर रहे रिजल्ट, ये सारा वैल्यूज का रिजल्ट. और वो डेटा फ्रेम जो बनाया था उसमें कॉमन एक कॉलम बना रहे स्क्यूनेस अंडरस्कोर कमेंट, उसमें ये जो स्क्यूनेस अंडरस्कोर लेबल में जो अभी लिस्ट है, जो ये वैल्यूज है ये सारे वो अपेंड कर रहे. एंड सेम गोज विथ कर्टोसिस लेबल. कर्टोसिस लेबल इज अ ब्लैंक लिस्ट. वी आर गिविंग दिस वैल्यूज एंड वो अपेंड कर रहे कर्टोसिस टाइप के लिए. एंड देन रिजल्ट अंडरस्कोर डीएफ कर्टोसिस कमेंट कॉलम बना रहे उसमें ऐड कर रहे. And then we are going to return our result underscore df, and this is what we have. So is it clear now for everyone? Do you have any questions in this? You can ask. Anyone have any questions in this? All right, if you don't have, we are going to start with the machine learning part now, because Python is completed. Python statistics, इसमें descriptive statistics is done for us, and advanced Python which we have studied, it is also covered. Then NumPy and Pandas, these libraries are done. Matplotlib is done. Seaborn is done. Right? Now we'll start with the machine learning part. But before that, let us have a quick break for 5 to 6 minutes. Once right after the break, we'll start with the machine learning part. So don't you, I mean, don't go anywhere. We'll just take this. We'll start with the machine learning part in today's session. So it's 12:14 now. We'll have a break till 12:20. So this is a very important part. Don't go or don't leave the meeting. So let us start with the machine learning part. So what is machine learning? Basically, we give some data to the system, right? And it will try to learn the patterns from the data, and it will try to predict the output. It will try to predict the output. Basically, this is your simple definition of machine learning. So we try to uh, create a model which will think like your machine, or it will think like your human brain. So similar to the fashion that we take up the decision, we will going to create a machine learning model which will try to give us the think like the human being to give us the output. So this is a simple definition. Now we have in machine learning, what do we have? We have two types basically. First is supervised machine learning, and another is your unsupervised machine learning. In supervised, as you know, we have target variable and we have independent variables, right? Suppose this is your case, this is your data set in which you have price of a house, you have square feet, number of bedrooms, and let's say number of balconies. This is your data, right? Now what you have to do is you have to predict the price of a house. You have to predict the price of a house. So what is the target variable over here? Price of a house will be your target variable. And use a SARIC column. Say by using that we predict the target variable. These are the independent variables. So square feet, number of bedrooms, and number of balcony. Use a column. Say these are your independent columns. These are your independent columns, right? Now, what do you mean by supervised is here we know or we have an idea about the target variable. What is your target variable? We have an idea about the target variable. But in unsupervised, we don't have any idea about the target variable. We don't have target variable. So what are the different examples that we can have under supervised machine learning? The examples are, let's say this example, predict price of a house, predict price of a car, right? We have predict whether customer will repay the loan or not. There can be n number of examples. So ये हो गया आपका supervised and unsupervised machine learning model. These are the types that we have. Is it clear what is the difference between supervised and unsupervised? Everyone? Is it clear for everyone? Now ये supervised में ही we have two types in supervised. We have regression and we have classification. What is regression? Regression means तुम्हारा टारगेट वेरिएबल है वो है कंटिन्यूस, मतलब दैट इज इन नंबर्स. ये टारगेट वेरिएबल इज इन नंबर्स. सो टारगेट वेरिएबल क्या है? न्यूमेरिकल. इसमें क्या एग्जांपल बन सकता है आपका? लेट्स से प्रेडिक्ट प्राइस ऑफ अ हाउस, predict price of a car, right? Predict price of a mobile, or of a computer, right? Or let's say predict marks scored in an exam, right? But when your target variable is continuous, when your target variable is continuous, sorry, categorical. Continuous means the numbers only. Numerical is nothing but your continuous. When your target variable is categorical, मतलब टेक्स्ट है. लेट्स से यस और नो है आपका टारगेट वेरिएबल के आउटपुट में, या फिर ट्रू और फॉल्स है, राइट? ट्रू और फॉल्स, या फिर you have let's say class 0, class 1, something like that. Then that is your classification problem. Let's say example is predict whether customer will get loan or not. Predict whether customer will purchase bike or not. This can be n number of examples, right? तो इसका आउटपुट क्या रहेगा? कस्टमर विल गेट लोन और नॉट. आउटपुट क्या रहेगा? यस और नो, राइट? इसका क्या रहेगा? कस्टमर विल परचेज बाइक और नॉट. आउटपुट क्या रहेगा? यस और नो. So this is your regression and classification. Is it clear now? Regression and classification. Anyone have any doubts in this? So if this is done, what we'll do is we will create new folder and let's rename this as linear regression. So let's see first. इसमें in supervised machine learning we have different algorithms, machine learning algorithm. तो supervised के अंदर we have linear regression, we have logistic regression, decision tree, right? Random forest, noise bias, SVM, boost, KNN, G boost. ये सारे मशीन लर्निंग मॉडल्स हैं. और अनसुपरवाइज में आपके अलग है मशीन लर्निंग मॉडल्स है. अनसुपरवाइज्ड, what do you have is you have K means hierarchical clustering, K means clustering, hierarchical clustering, and you have PC. So ये सारे algorithm we are going to study one by one. Now let us go with linear regression. I'll just quickly open new notebook. And let's rename this as linear regression. Now, in this thing, I just yeah. So we'll require data for this. First of all, so data is car MPG student. Hmm. Now, in order to follow, in order to linear regression, it should work. There are some assumptions. तो ये assumptions follow करने चाहिए आपके डेटा में, तो ही आपका linear regression work होगा. So this is very this is not flexible model. इसके लिए assumptions बहुत सारे. Now what are the assumptions that we have? I'll just copy this. What are the different assumptions that we have? Let's take it. I'll just take this and I'm going to paste it over here. These are the assumptions that we have for linear regression. So first assumption, what is first assumption? Linear regression needs linear relationship between independent and dependent variable. Linear regression is very sensitive to outliers. It is very important to check the outliers before performing regression analysis. Now, what do you mean by this? Let us take it over here. And let us paste it. First क्या है तुम्हारा linear regression needs linear relationship between independent and dependent variable. So अगर आप एक independent variable or dependent variable, let's say price of a, or let's take price on x-axis, y-axis, price of a house, ये आप y-axis पे ले रहे हो and x-axis पे क्या ले रहे हो? Let's say square feet area. तो सपोज ये दो कॉलम है आपके डेटा में, यू आर प्लॉटिंग इट ऑन द x and y एक्सिस, तो उसका ग्राफ सिर्फ लीनियर ही रहना चाहिए, आइदर इंक्रीज और डिक्रीज लाइक दिस. इट हैज टू बी लीनियर रिलेशनशिप. व्हाट डू यू मीन बाय लीनियर रिलेशनशिप? What do you mean by linear relationship? It simply means if one variable is increasing, other variable should decrease. It means this thing. If one variable is increasing, other variable should other variable should increase or decrease, not decrease only. It can increase or decrease. So ये है linear relationship, right? So it's just like this. अगर आपका ग्राफ ऐसा बन रहा है like this और कर्व के फॉर्म में बन रहा है, तो your linear regression should not be the, उसके ऊपर आप linear regression नहीं फिट कर सकते आपके मॉडल, आपके डेटा के ऊपर. सेकेंड पॉइंट क्या है? इट इज वेरी सेंसिटिव टू आउटलायर्स. तो अगर आउटलायर्स रहेगी आपके डेटा में तो आपको रिमूव करना होगा वो. So how, what we do generally to check the outliers, we plot the box plot, right? तो अगर box plot आप लोगों ने plot किया and if you find that you have outliers in the data, then what happens? You have to remove that outliers. Is it clear? Second is normality. Linear regression requires all the variables to be normally distributed and error term should also be normally distributed. Now we'll try to understand what is the second assumption that we have. देखो ये सपोज आपकी रिग्रेशन लाइन है और ये आपके डेटा है. These are the data that you have. What is error term? Error term is difference between your data point and the regression line. Distance between your data point and the regression line. अगर डेटा पॉइंट एंड रिग्रेशन लाइन में डिफरेंस और डिस्टेंस रहेगा तो दैट इज योर एरर, राइट. तो ये सारे एरर टर्म, एरर, और इसको बोलते हैं रेसिडुअल एज वेल. सो सपोज ये जो लाइन है उसके ऊपर जब डिस्टेंस है दैट इज पॉजिटिव डिस्टेंस और पॉजिटिव एरर, नीचे है दैट इज नेगेटिव एरर. सपोज ये 4, ये 3, ये 2, ये -2, ये -3. So these are the errors that you have. Now what does this assumption says? It requires all the variables to be normally distributed. So अगर आप distribution, आपके डेटा का distribution निकालोगे, it should be normally distributed. What is normal distribution? It is a symmetrical distribution. You should not have skewness over there. इसको बोलते हैं normal distribution. If you search what is normal distribution, you'll get an idea about this. In normal distribution, it's a symmetrical distribution. मतलब left hand side में और right hand side में it has to be same, right? Symmetric about the mean, showing that data near the mean are more frequent in occurrence than the data. So ये है आपका definition. So what does this assumption says? कि your linear regression requires all the variables to be normally distributed and the error term should also be normally distributed. तो अगर आप error term का भी अगर data set बना रहे हो 2 3 4 -2 3, suppose ये error term है 2 3 4 -2 -3 -2. So ये भी है इसका distribution. If you plot, so it should also be normally distributed. 50% to the left hand side, 50% to the right hand side, right? Is it clear now, everyone? Do you still have any questions in this? Now third is multicollinearity. ये अपन लोगों ने देखा था, right? There should be little or no multicollinearity in the data. Multicollinearity happens when the independent variables are highly correlated. So we already have discussed this, if you remember. Multicollinearity के लिए what we do is I'll just show you where we have done this. In data visualization, we have discussed this. chain. Hmm. Here we have seen, right, multi-collinearity. If the correlation between the independent variable is greater than 30%, then that is multi-collinearity, right? In this data, we can see that 56 है, 51 है, 56 है, we have 90. So we can say that multi-collinearity exists. See, this is what we have discussed, right? So if the multi-collinearity exists, we have to remove that by this VIF and tolerance. We'll see this thing, what is VIF and what is correlation matrix. But we already have discussed this. By just having a look at correlation matrix, we can detect the multi-collinearity, right? Then we have homoskedasticity. The error terms must have a constant variance with respect to a regression line. This phenomenon is known as homoskedasticity. The presence of non-constant variance is referred to as heteroskedasticity. Now let's have a discussion on these two assumptions. What is homoskedasticity? Error terms must have constant variance with regression line. तो अगर आप error terms, if you just if you're just plotting the regression line, तो ये जो error terms error, suppose these are the data that you have, must have constant variance. तो variance का meaning क्या है? What do you mean by variance? We have seen this in the last session. It is the average squared distance of each data point with respect to mean. Average square distance of each data point with respect to mean. So if you calculate the आप वेरिएंस निकालोगे तो it should be uniform throughout the regression line. ये है आपकी regression line. तो वो जो distance है that has to be uniform. If you just if you just see homoskedasticity, you'll see this example or figure. So this is your homoskedasticity and heteroskedasticity. So I'll just take this out. I'll just push it over here. So error terms must have constant variance with respect to regression line like this. देखो distance है throughout the regression line. ये regression line है. Distance vary नहीं हो रहा है क्योंकि uniform है, right? But यहाँ पे देखो इसका अगर distribution निकालोगे, it is varying like this, right? So error terms do not have a constant variance with respect to regression line. Similarly, यहाँ पे भी देखो, if you just try to plot, it is like this, right? So error term must have constant variance with respect to regression line. तो ही आप linear regression model fit कर सकते हो, homoskedasticity. And what is autocorrelation? We'll just try to understand that. So there should not be any correlation or very little correlation in independent variable. See, degree of correlation of the same variable between two successive interval. It measures the degree of similarity between the given time series and lagged version of the time series over successive time periods. So if you're not understanding this, let us take the same example. What is autocorrelation? So if you just say you have sales data for the product. So for an example, जैन में आपका सेल है 15, फेब में आपका सेल है 25, मार्च में आपका सेल है 35, अप्रैल में आपका सेल है 45, मई में आपका सेल क्या रहेगा फिर? What will be the sale if you just see this pattern? Can you write down in the chat? What will be your sale for May? Yes. What will be your sale for May? May. It will be 55, right? So ये जो है previous month के साथ अगर relation है, तो it is known as auto correlation. This term is known as auto correlation. So if you just see, यहाँ पे वही explain किया इन लोगों ने. Degree of similarity between a given time series and the lagged version of the time series over successive time periods. So आपका linear regression क्या बोलता है? There should be no correlation between the residual terms. Absence of this phenomenon is called as autocorrelation. So correlation भी नहीं चाहिए residual और error terms में. अगर नहीं रहेगा तो वो है autocorrelation. So this is what we have. Now we'll just try to build the linear regression model. ये हो गया theoretical part. So basically what we do is we try to fit our data on x and y axis. उसके ऊपर रिग्रेशन लाइन फिट कर से ये रिग्रेशन लाइन का इक्वेशन रहेगा स्ट्रेट लाइन इक्वेशन y इक्वल टू mx प्लस c. इसमें एरर टर्म्स देखते हैं बिकॉज ये जो डेटा है वो x और y एक्सिस में प्लॉट करने के बाद में वी ड्रॉ दिस रिग्रेशन लाइन, राइट? तो द बेस्ट रिग्रेशन लाइन कैसे रहेगी? बेस्ट फिट रिग्रेशन लाइन, व्हाट इज योर बेस्ट फिट रिग्रेशन लाइन? इट विल बी अ लाइन where or which does not which has very less error. तो ये सपोज ये लाइन का एरर है 15. तो अगेन वी गो एंड प्लॉट द डिफरेंट रिग्रेशन लाइन, लेट्स से लाइक दिस. तो सपोज ये लाइन का एरर कम है 10. देन अगेन वी डू द ट्रायल एंड एरर. वी गो विद दिस रिग्रेशन लाइन. सपोज थर्ड रिग्रेशन लाइन का एरर है 2. Then we'll stop key जहाँ पे minimum error रहेगा, we'll stop that. This is your equation. So this is how your linear regression works. Now let us import the necessary libraries. Import pandas as PD. Import numpy as np. Import matplotlib.pyplot as plt. Import cborn as sns. ये हो गया आपके necessary libraries. We'll read the data. So I'm giving the heading as read the data. EF is equal to pd.read underscore CSV. In quotes, you have to give the name of the data, and then you check the head of the data. This is your head. And then we'll go with the EDA part, which is known as exploratory data analysis. In that, we'll write down df.info. We'll check whether we have null values or not. So df.isna.sum. We do not have null values, so we can move further with the next part, which is df dot describe, df dot skew, df dot kurtosis, and then we'll go with the outliers. So I'm giving heading as detecting the outliers in data. Yield dot figure, fixed size is equal to 20 comma 12, and df dot box plot vertical is equal to false. Now we can say that we have outliers in the data, right? Now to remove these outliers, we will create a function to remove the outliers. We'll see this in tomorrow's session. So I'll quickly give this to you on your drive. And if you have any questions, you can ask in this. So machine learning, and in Python, we will require this is your linear regression. So I've given everything on your drive. If you have any questions, you can ask. So just practice this, and we'll see the next part in tomorrow's session. Yes, is it clear for everyone? Do you have any questions? All right, then we'll stop here for the day. Thank you and happy learning. Bye.